Kia ora koutou. This question is from the 2012 November Pure 3 paper, and it's a partial fractions and binomial expansion question. It's really boring, but it's kind of good practice, and it's very easy to make small mistakes in these. So I want you to have a go at it first before you watch it. If you're in my class this year, then this is one that I've set for tomorrow while I'm away. So please don't watch this until you've tried it. So the first thing we have to think about when we're doing a partial fractions question is what's the right format to break down this into a bunch of partial fractions. So let's have a look at that first, because if we get that wrong, there's really nowhere to go. So we can see here we're going to have this as one denominator and this is another denominator. 3 minus x here and 1 plus x squared here. Now if you're having trouble remembering the next bit, what we've got to generate when we start cross multiplying is a quadratic. So you can see that we're going to get a quadratic thing out here even if we've just got a constant. This though is a linear factor, so to get other bits of the quadratic we need to have another linear factor up here. So that's the quick revision of what we did earlier this year when we looked at all of those different forms of partial fractions. Now you need to know those, you're not given them. So if they make a bit of sense, it's easier to remember what's going on. Next thing we do is that we cross multiply and we get the denominators equal. So 9 minus 7x plus 8x squared has got to equal a times 1 plus x squared plus bx plus c times 3 minus x. Okay, there are several ways to go here, so I'm going to use a combination of matching up coefficients and substituting in. There's only one value that I can substitute in for x and make anything over here 0, and that's x equals 3. So I'll start by doing that. So let x equal 3, we're going to substitute that in on this side and then on this side. So 9 minus 21 plus 8 9s are 72 is equal to a times 1 plus 9 plus 3b, what have we got here? Oh, of course we've got 0 here, plus 0, that's the whole point. Okay, so we've got 60 is equal to 10a, a must equal 6. Now I've done my substitution, I'm going to start by doing some matching up. So the first thing I'm going to match on is the constant. 9 has got to equal, well, a times 1. So 6 plus the constant in here is coming from the 3 times the c. So 6 plus 3c. That gives me c is equal to 1. Now I can match to get b, I can match on the x term here, or I can match up the plus 8 squared, plus 8x squared. I'm going to match up the 8x squared. Right, so we've got 8x squared here, we've got ax squared here, take away bx squared here. So 8 is equal to 6, 6x squared, what have we got next? Minus bx squared. Right, so let's look at that again. I've got 8 here, ax squared here, minus bx squared here. So that tells me that b has to equal negative 2. So we've got those three bits, we're ready to put it all back together and write the expression out. And after that we're going to have to do binomial expansion. So 9 minus 7x plus 8x squared over this is equal to 6 over 3 minus x plus, now I'll write this the other way around, 1 minus 2x over 1 plus x squared. That was the first part of the question done, so that's I think 5 marks. Yep. And now we've got to obtain the expansion of this in ascending powers of x up to and including the term in x cubed. So what we're trying to do is to take this and to take this and expand them out and in the approximation we can stop when we get to a cubic. It's really easy to go wrong here, so I'm going to do the two expansions separately, then I'm going to add them together, and I'm going to watch out for my place value as I go. So 6 over 3 minus x can be written as 6 times 3 minus x to the power of negative 1. I'm forcing this into the pattern that I need for the binomial expansion to work. So I've got to have a 1 plus something to the power of something. So I'm going to take out this factor of 3 and go 3 times 1 minus x over 3 to the power of negative 1. That gives me 6 over 3 times 1 plus negative x on 3 to the power of negative 1, which is looking pretty good. So I've got 2 times this. Now I'm ready to go with the binomial expansion, so that's roughly equal to 2 times 1 plus nx, so negative 1, times whatever this factor is, plus negative 1 times negative 2 over 2 factorial times negative x over 3 squared. I've got to get to a cubic, so I've got to go one further. So if you're rusty on this, it's time to go back into the textbook and go back over the chapter on binomial stuff. Right, what we've got to do now is to clean that up. So that equals 2 times 1 plus x on 3 plus x squared on 9. Here, this works out to be negative, so it's going to be plus x cubed divided by 27. So it's 2 plus 2/3 x plus 2/9 of x squared plus 2 over 27 x cubed. Now I'm writing it like that with the coefficients sitting up the front because I'm going to have to combine these with the next bit in a minute. So let's turn now to the second one. The trick here is to remember that the thing I'm going to be expanding is 1 over 1 plus x squared, and then I'm multiplying it by 1 minus 2x. I'm just getting the approximation to go as far as the cubic term. So 1 minus 2x over 1 plus x squared looks really horrible, but it's not. It's 1 minus 2x times 1 plus x squared to the power of negative 1. The good thing about this is that this is already in the form that I want for my binomial expansion. So this is equal to 1 minus 2x times 1 plus nx, so negative 1 times x squared. Remember, I've got to go as far as the cubic thing. But because I've got an x squared in here, you can see that here I've already gone further than I need to, because this is x to the power of 4. So this is roughly equal to 1 minus 2x times 1 minus x squared. So we're just going to expand this out, and we'll get 1 minus 2x, 1 minus 2x minus x squared plus 2x cubed. So that's as far as we have to take that. So we've got our two separate expansions done, and we've just got to add them together. So the whole thing is roughly equal to this. I've got 2 plus 2/3 x plus 2/9 x squared plus 2/27 of x cubed plus 1 minus 2x minus x squared plus 2x cubed. I like lining them up in place value order because it makes it much easier to work with the fractions. So that equals 3 minus 4/3 x minus 7/9 of x squared plus 2 and 227. So 56 over 27x cubed. Let's just go back to the question and check that we've answered everything in there. I think we have. Oh, there's the question here. Yep, so we have to obtain the expansion in ascending powers of x up to and including the term in x cubed. So just quickly wrapping up what we did. The first thing we did is that we had to express this in partial fractions. So the key thing we had to remember here was the form that it was going to take on. And it was a linear factor here and a constant factor here. And then we went through as usual and we worked out a, b and c. Then we took that and we split it into two. So we had two separate binomial expansions and we just had to go up to the term in x cubed. Alright, so it's 10 marks, 10 pretty fiddly marks, but conceptually pretty easy compared to some of the other problems that we've been solving. Thanks for watching. Hopefully, if you are having trouble with this, go back to the early parts of the Pure 3 textbook and work through some of those examples.